In this video lecture, we're going to focus on weather fronts and what they mean when we look at a weather chart. So the first one we're going to look at is a warm front. A warm front has red semicircles associated with it, and it's the semicircles that actually mean something. The semicircles are rounded, soft. This indicates that warm air gently glides across the landscape. So in the fronts always indicate, or are always on the side that it's going to be moving. So in this case, we have a warm front that is moving toward the north. So again, this is the warm front. And everything behind that front is warm air, The next front has triangles. It's blue and has triangles associated with it. And it moves usually toward the southeast. Cold fronts, again, are blue in color and have triangles associated with it. The triangles indicate a sharp, abrupt movement. So it is a quick movement because the air behind this is extremely cold and very dense, so it moves quite quickly. All right, the next front is a combination of both warm and cold air. And basically, you have cold air coming from the north, and then you have warm air coming from the south. So these air masses here, these two different air masses, are basically butting heads. Neither air mass, the cold air or the warm air, is strong enough to outdo each other. So it doesn't move very much. A stationary front indicates that it is very slow moving or not moving at all. All right, next one is an occluded front. Occluded front. Here, this front is purple with triangles and semicircles alternating on the same side. This indicates that both warm air and cold air, or basically the cold air has removed the warm air, and it is removing the warm air. So the occluded front, again, the triangles and the semicircles are alternating on either sides of the of the front. All right, the next and final front is called a dry line. Here we have a dry line where we have semicircles that are packed in together and usually a yellow or an orange color. And it indicates that there is dry air behind it. Dry air behind it. We usually see this front in the southern Great Plains. All right, now let's take these fronts and look at two different scenarios, a cross-section of a warm front and a cross-section of a cold front. The first one we'll do is a cross-section of a warm front. Cross-section of a warm front. Here is the surface. Okay. Now I'm going to go ahead and draw off to the side how this looks on the chart, because we're looking at this like a sliced piece of cake. And so if we have a low, we have a warm front there, cold front here. We slice it here, A and B. This is A and this is B. Warm air is just south of the warm front here. So this is all warm. All right, and then this is cool, old air ahead of the warm front. Okay, so here it comes. We have a warm air mass. And what it does, as I said earlier, warm air glides gently over cool, old air. So the warm air mass moves in from the south, and as it does, it glides gently over cool, old air. As it does, as this air glides gently over cool, old air, it creates clouds. In fact, these clouds are stratiform clouds. Stratiform clouds. So the first thing, if you're standing here and this air mass is moving in, the first thing that you'll see is not a stratus cloud, but it is a cirrus cloud, wispy clouds. And then next you'll see cirrostratus clouds move in. Then you'll see altostratus clouds move in. We see these clouds getting closer and closer to the surface of the Earth. Then we see stratus clouds, starts to get more of an appearance of dark and gloominess. And then finally, as the front approaches, which is located here, the front, the air mass front, which is the warm front, this, is moving in, we start to see rain appear, and that is the nimbostratus cloud. So again, the cross-section of the warm front is taking from A to B, and the warm air mass is moving in from the south. It is gliding over cool old air, creating clouds that take on the stratiform appearance. The next cross-section is the cross-section of the cold front. The cold front. Right? And I will draw this again. Start fresh. So this is the cross-section of the cold front, where now the dominating feature is the cold air mass. So here's the low, here's the warm front. Ahead of it, here's the cold front. You take a slice here, Y and Z. So here's Z, surface, Y. All right, this is warm air here, and this is cold air back here, behind the cold front. The cold air mass, as I said before, is heavy, dense, and it's an abrupt motion. It's very dense and weighs a lot, and it just kind of pushes along the surface of the Earth. So we've got an abrupt motion here, cold air. As it moves in, you've got warm air on this, on the side that it's pushing towards. So what happens is you get warm air that rises above it, and as it does, it creates cumulonimbus clouds, the thunderstorms. So we get thunderstorms near the front. In fact, we have it in front of the front. So again, this is an abrupt motion. We have cold air that pushes in, and it pushes warm air over the top of it, creating a cumulonimbus cloud, or a thunderstorm.